Let's go over what's changed. First of all, let's move to this shader right here, which is a view of the sub-portion of the master memory that we will be using to encode uniform values. So it is an 8 by 8 block. If I press the number 0 through 9 on my keyboard now, you see this turns white. It's actually encoding a value here in this pixel, but because of the order of the bit packing, the alpha channel gets the number 0 through 9, and then all of the other channels end up 0. So, you know, it's a very, very, very transparent black color is what we have right here, right now. So that could make it a little bit hard to visualize the data, because every point where you have data, it just kind of just makes a hole in your texture. However, it's the most straightforward way to get the data there, because I'm just packing and unpacking the bytes. I'm not doing anything fancy. Let's go to the code. So I'm just going to review what's changed by scrolling down through it in its entirety and stopping at the bookmarks again. So let's keep on scrolling. And okay, so in our init global configuration, I was messing around here with different areas to map the subregion of the master memory where we're storing these values. Let's change it for a second. So let's use 4 and 4 here as well. So this is going to be a 4 by 4 rectangle now. And let's go back to here, and we're going to refresh and take a look. So now you can see we got 1, 2, 3, 4 areas. If I press a number key, you'll see this pixel, once again, is putting data there. Let's go back here, and let's try something else. Let's try, say, 16 by 16. And also, right now the variable is being stored at the first pixel index. Let's put it somewhere else. Let's put it somewhere on the second line. So let's say 16, 24 should be somewhere on the next line, right? Somewhere in the middle. So let's put that at 24. Let's go back here. Let's see what that looks like. So we're going to refresh. And then we're going to move over here. So you can see there's more information allocated for these uniforms that are mapped to the texture. And if we press a number key, we can see that the data is now stored at this pixel location within this subregion. So this shader right here that I'm showing you, it zooms into the entire subregion that you've allocated on the master memory. And that's why we're seeing more little squares as we up the resolution of that subregion here. Okay, so you've seen that, and that should kind of make sense. Let's keep on going. Oh, one more thing. So the way I've named this, right? So this is just saying that this is, you know, the first memory subdivision. So it's numbered number 1. And I'm going to associate this specific constant with editor 1. And the variable name within editor 1 is going to be called dex SHA, or the index of the shader. So that's kind of obtuse and very procedural looking, I guess, because I'll basically be collecting a big linear index of all the variables that are used in the code is what's going to happen here, or at least all the variables in the code that need to have some type of representation on the GPU. They will be kind of stored like this. So let's change this back to 8 and 8, because the initial intention was just to keep that 8 by 8 region, and now this would obviously overflow. Oh, actually no, because 8 and 8 is 64, so we could still use that. Let's look at what that looks like for a second. So let's refresh. Okay. And now if we press a key, we can see a spot right there. Okay, anyways, I'm going to change that back to 0. I have confidence that it works. Now I've also translated these rectangles as well, and it still works. We could do that. Let's do that. So right now you see this diagonal of different colors. I intentionally put those there so I could get my bearings. Let's try to move this 1, 2, right? So that we see the blue up here instead of the red. So 1 and 2. We're going to go to the code, and we'll just add 1 and 2 and 1 and 2. Okay. So now when we refresh, we're going to see this blue right up here where that red is. So refresh. And now you can see the blue up there, right? And we have the 8x8 region. So 1, 2, 3, 4, 5, 6. Oh, no, it's 6 because we inset a little bit, right? Because we're starting at the index 2. Right, because I'm using an inclusive rectangle here. But that was what I expected for the results. So let's put that... Ooh, actually, before I do that, let's make absolutely sure that when I press a key, it maps correctly and doesn't do anything weird. All right, awesome. So that looks good to me. I guess the next test we could do before we're totally done here is we could say... so this is 6. 6 times 6 is 36. So 35 should be the last 35 should be the last index. So I'm going to save that there. Then when we go over here, I'm going to expect, instead of this being white, I'm going to expect down here to be white. So let's refresh that, and we'll go back to that shader. And we're going to press a number. Okay, the number is encoded here on the texture now. So that looks awesome. It can be translated, the rectangle can be translated and scaled, and everything still maps correctly onto where I decide it's going to go. So we're going to change everything back. So change these back to zeros because I want that at the origin. And 8 minus 1, right, because it's 8 by 8, and it's an inclusive rectangle, so it's the values 0 to 7 inclusive. Okay, let's keep going. Let's see what else we got. Okay, I don't know if I cover this, but the texture as uniform controller, an instance of it is made right here. You'll see that this is TAU001, and that's because it corresponds to these hard-coded constants, which also are named TAU001. And that'll make it easier for me to know which one of these instances of the texture as uniform controller is associated with what, because we may have more than one of these in the future, and I'm just going to name them by number and just index them. Let's keep going. So the texture as uniform controller, it needs a little bit of configuration. First of all, we're going to give it a instance name of TAU_001. We're going to borrow a pointer as weak reference, and it needs the U32 pixel container. And we're going to grab that from the master memory allocation in the adapter graphics. Then we need to put the current rectangle bounds, like where that memory is mapped. So we'll use this function, and we'll set those constants of the x0, y0, x1, and y1. Okay, let's keep going. I think I already kind of covered this, but now we have the texture as uniform controller number 1 in there as well. It needs to be between the adapter graphics and the adapter variables, because adapter variables may reference either one of these two objects. Let's keep on going down. I'm going to just stop when I hit a breakpoint, but I'm kind of scrolling so you can get the big picture of everything here. I don't really expect you to be able to transcribe from the screen or anything, but it's just to help document, or my own personal documentation, I guess. Alright, so I think I just, I was running into some trouble, and I don't know if I covered this already, but my formula needed the division by width and the division by height, because I got my fragment coordinates and my UV coordinates mixed up. And it's a UV coordinate, so it's supposed to be normalized, and I, for some reason, didn't think that. But yeah, when you're using a texture sampler, even if the texture is an integer texture, you still need to sample with float coordinates, and I totally screwed that up. So now, when this texture is doing its sampling, we get the correct results because we had like all these tests written over here previously to check for out of bounds access, and none of those tests were showing up on screen. And so I kind of knew that the problem was somewhere in the texture sampling. Well, not the texture sampling, but the fetching of this coordinate specifically for sampling the master memory. Let's keep going. So this is sampling the textures as uniforms set number 1 and using the index location of the variable. So this is, if we want to grab a uniform value that's mapped onto the texture and we want to grab it by index, we will use this function. We just have some math here to convert the index into tile x, tile y, or pixel x, pixel y, whatever you want to call it. And then we call the texture as uniform set number 1 sampler that uses position instead of index, and we just send it that txty. And where is that? Did I already go over? Okay, yeah, we already went over that, so let's keep on scrolling. If it doesn't have a bookmark, I'm going to kind of assume that I have covered it previously. That may or may not be a mistake. There's a little note here that I want to unhard code these values, but that will be at a later date. There's some other things I want to get out of the way before I unhard code the viewport size. Scrolling down, there's a lot here. Pretty soon I'm not even going to be able to have time to scroll through everything and do it in under 20 minutes. Right here is just all these breakpoints right here. It's inside of our debug fill pattern pyramid, and all I'm doing is just adding, you saw that diagonal of colored pixels, right? That diagonal. Those are manually added at different diagonal points. So we got black, we got red, we got green, we got blue, cyan, yellow, and magenta. And that's just so when I was doing some of the code, I wanted to get my bearings and see exactly where I was on the texture. And I couldn't really tell that with just a plain checker pattern that's uniform throughout. It's not quite uniform without, but when you're zoomed in that much, it's pretty much uniform. So also I kind of like, added these dashed lines to help organize the sections of code. And then the main pyramid pattern is down here, which we've already kind of gone over. Let's keep on scrolling. I cleaned some stuff up. So here's main, and you'll notice that there isn't anything between main and the uniform helpers. There used to be a whole bunch of to-do notes, I believe. I moved those to the bottom of the file. Let's keep on scrolling. Okay, scrolling. Okay. I think that we already covered this, but I added some code to make sure that we ignore caps lock when it's on. Because right now we only have one event object, and we have to use it sparingly. To do keyboard and mouse inputs. Well, that is done, so I don't know why that's just kind of there, wandering around. But let's just delete that. I'll worry about the exact spacing maybe later. Scrolling around. Okay. So loop table tick and the render logic. So this would be in our game loop, and this would be the render logic component of our game loop. And we have the texture as uniform controller number 1 and uniform commit. Okay, so when we're messing with all the uniforms within the code, we're only going to do one push of all those uniforms to the texture, right? Because if we tried to push individual pixels to the texture in separate calls, that would totally defeat any optimizations that we have going here, right? We want to do things in as big of batches as we can. So in texture as uniform controller, there is a uniform commit, a uniform put, and a uniform get. It's also important to note that the uniform get does not take the data off of the GPU. It just looks at the local cache, and the code makes sure that the local cache of the data is synchronized with the GPU side cache of the data within the texture. Okay, so we're going to clear, and then we're going to draw arrays. Nothing fancy or different there. And keyboard numbers. Okay, so there was some logic that I did eventually have to reuse. So I put it here. It's global event dot keyboard number. So I've written it in a procedural style, but I have a convention where I'm going to, read it as if it were a member function. So this is my namespace. This is the object instance. And this is the function name. So it's global event dot key number. And when you're using an object-oriented pattern with with code that does not natively support object orientation, you put the self argument as the first argument. Technically, we could make a more complicated object. We could tack on member functions to our global event, but the idea is that the global event is just supposed to be a struct, and it's supposed to be data, and there's not supposed to be functions mixed in there. So in order to get kind of like that OOP feel without, making our struct into a class or otherwise just tacking stuff on, I don't want to. This object, the global event object, it's good as is. We're not going to muck it up by adding a whole bunch of methods to it and turning it into a class. We're not going to do that. Anyways, so global event.keyUp and global event.keyDown. If neither of those are set, we're just going to return a -1. So this is expecting a global event that is configured as a keyboard event. And because of how I'm using this, I could not make this throw an error. So it will fail by returning a -1, and so you will just have to handle the -1. And then we just have this big map of different values for the key that map to different numbers. Okay, anyways, let's keep on scrolling. This looks like a complete disaster. So this is obviously some shader code. So A2JS fetch shader code and then the editor mode, right? So different shaders are going to be strongly associated with different editors. Okay, how did I say that right? Different editors are associated with different shaders. And the editor mode tells us, which editor is currently in focus. There can only be one editor in focus at a time. And depending on what editor that is, we use different shader code. And this is just the code to inline the correct shader code within the editor mode switch within the main shader code. So this is editor 0's code, and this is editor 1's code. And we don't have anything else for the other editor numbers yet. Oh, I think we probably just return an empty string. It says code up there. Oh yeah, code equals an empty string. So if there's not any code for a certain shader number, we just return an empty string. And we do have some breakpoints, so let's look at those. So VP1 width and height. Oh, so there's just a note here that we need to unhardcode this. But before I unhardcode this, I have to actually add a uniform that's encoded within the texture to store these values, and I haven't done that yet because the first thing I want to get to is make a little shader sampler. I'm going to turn editor number 1 into a shader sampler, or actually editor 0. Okay, so let's actually no, not editor 0, because editor 0 is actually the editor all. So we're numbering our sub-editors starting at 1. So therefore, editor 0 actually corresponds to editor all, which basically means that this is the shader when no sub-editor is within focus. Okay, let's keep scrolling. What time do we got here? 19 minutes? Okay, we're not too bad. So we got a struct section. That's nothing new. Okay, that's nothing new. Nothing new. Okay, so we have messed with the adapter variables. Adapter variables, when I initially wrote it, I had not implemented it. I just was kind of like sketching out my thoughts in a different text editor at one point in time and kind of fleshed it out to where it started to, where it didn't have any syntax errors, but I didn't know if it worked yet. And now we have it working. And now that we've had it working, there's, just a few things that needed to be added to actually get it working. So you'll see these are our bootstrapping uniforms, like the most important uniforms. And they don't really have a namespace attached to them. They're kind of like grandfathered in at the top level. And then, did I say this is my uniform as textures thing? Because that's a lie. This is adapter variables. This is not, that is not what this is. This is just a wrapper to encapsulate how these variables are accessed, so that depending on how we want to store those variables on the GPU, or if those variables need to be synced with the GPU, that we can manage all of that without having to worry about those syncing details within every single class. So the pattern is going to get kind of weird because this adapter variables class is probably going to get huge because it will be a master index of getters and putters for every single variable that needs some type of an association on the GPU, or might need an association on the GPU. So basically, any editor that any editor's public data is probably going to have to filter through this adapter variables class. So right here, let's look at this. So the editor1 variables, we have a put and a get, and this is for editor number 1, and this is the variable name, the index of the currently selected shader, because I'm going to make editor1 a shader sampler where you press the keys 1 through 0 and you just get to see a different shader, right? So that I can experiment with writing shaders and have an editor where I can kind of quickly flip through what different shaders look like, So it's a shader testbed, basically. Editor number 1 will be a shader testbed, which will help in my development as I'm, writing code. So in a way, editor 1 is my bootstrapping editor, because it's not really meant to be something used in the production. Like the final product is going to have no use of this, and it's like a scaffolding piece that's kind of like will be hidden away. Kind of like how some games have like a debug mode that they never take out, but it's hidden away. Okay, what else? So here is the code for putting the index of the selected shader and getting the index of the selected shader. You'll notice that we are using the texture as uniform class with both of these. So texture as uniform put, and then we use those constants that are defined in the configuration, the global configuration. And I have it written so that it's lined up here so that I can easily visually identify that this is correct, right? But we have to specify the location of where the data is stored on the GPU, and then we have to actually supply the value we want to put on the GPU. And this is all kind of very bulky and ugly, and that's why we have this adapter, so that we can just call this function and not worry about this like ugly implementation side detail. And then also, if we decide later that we don't want to store it on a texture and we want to use an actual uniform, we can change this implementation. Like maybe I decide, oh god, this is a horrible mistake, it's causing pipeline stalls, let's fix this, right? We only have to go into the adapter's code, and we don't have to mess with any of these call sites, So for the So for the get is the same thing as the put, right? But in reverse. So the texture as uniform container number 1, uniform get, the texture as uniform container 1 constants for editor number 1, and the variable name here. What else? Let's keep on scrolling, I guess. You still got time? Okay, 25 minutes. So I'm not sure why there is a breakpoint by invoke hotkey. Oh, yes, because all this stuff went into into a function, right? We went over that a little bit earlier, and we probably have the function call somewhere near this, right? Yeah. So the key number. Okay, right here. So this key number right here is the replacement for all of this logic right here. So we look at the global event and figure out what key number it is, and then rather than doing this, big repetitive thing like this, which was fine to start with, but instead of writing, but now that we're reusing this kind of logic, it didn't make sense to cut and paste a big block like this and then just change all of the individual function calls inside of it. So we have a thing called put editor mode, right? This function right here, put editor mode, and then we just call it with the key number rather than doing this. This was fine to start with. It is fine to start out very verbose, repetitive, and dead simple, and then make it more complicated later, because the less elegant solution here, it's dead simple and it's very hard to mess up, and it gives you time to wrap your head around what you're doing before you delve one abstraction deeper and do something more complicated. Don't go straight towards the complicated abstraction. Be fine with doing something dead simple to start with, because that'll give you time to wrap your mind around what you are doing and how to best simplify it later. You need time for those ideas to percolate. So what else? I'm really not completely happy with the keyboard listener, but it's good enough to get us going. Okay, so the editor number 1. So it has a base class name, so var base, and then var type, and type is basically the superclass. No, not superclass. The subclass or derived class. I always have to flip that tree in my head because I never drew trees upside down like you do in computer science. I didn't know that's the way people did it. But once you realize that trees are drawn upside down, the superclass and subclass starts to make sense. But I still get it mixed up sometimes, so I like to just stick with base and derived class. So this is the base class, and this is the derived class. The reason why it's named variable type is because this was grandfathered in, and so we're not going to change it around. It's just that variable type can also mean the derived class. So we can write a little note here while we're at it. Derived class. Okay, let's see. What do we have here? Right, we're using that keyboard number fetching function here. And right, I had to use it in 2 places. That's the reason why it's been refactored into a function. I'm only going to refactor something into a function if I use it in more than one place, which it is. So rather than having a big block of code, we just call the put editor number 1 shader index, and we set the shader index here, which will be a value between 1 and 9, including 0. Oh, so between 0 and 9. And let me look at this for a second. So if the keyboard number is greater than or equal to 0. Okay, so technically, if I had some logic that mapped A through Z to the numbers that came after 1 through 9, this could set values that are higher. But right now, that's not the way the logic works, and it's gonna return negative for the letter keys. It's only gonna return a number for the actual number keys. I might change that in the future, or have a little condition that says if the number is between 0 and 9. Okay, we gotta wrap this up because we're at 30 minutes. So I had to think about what I was going to call this name we're in the textures as uniform controller. I decided to go with an obnoxious name that kind of, I don't actually have a functional weak reference, but it's supposed to be used as a weak reference. So I say borrow pointer as weak reference, and that sets the borrowed pointer variable right here. What else? This is just really for my own help in the debugger, and we saw this put rectangle bounds at the beginning when I was going through the initialization for the global classes. Or actually, this might not have been global. Yeah, this was for global classes because we need to know what memory we are mapping the texture uniforms to. Okay, so we got the variable type and the variable name. Oh, hold on. So we kind of did something slightly different here, didn't we? Oh no, this is the instance name. So this is still derived class. And this is yeah, okay, that's still good. I was just making sure I was being consistent with my logic there. Let's go down here. Borrow pointer as weak reference. It's going to take a U32pix object, so it's a pixels container, and we're just going to set that borrowed pointer to U32pix. I've also, lined it up to make sure that I haven't made any typing mistakes or assigned the wrong thing. Okay. So putting the variable name, pretty self-explanatory here. Putting the rectangle bounds, this is also pretty explanatory. So we have the different values that can be set for that rectangle, and then we're just setting them in here. This is kind of verbose because I did some error checking, and if I ever do this kind of logic again, I will put this into a function as well. But if I only use it in one place, I'll just keep it in one place rather than extract it into a function. Okay, so uniform commit. So this was a big... I'm going to stop here.